You can't really talk about the natural history of Earth without discussing the fossil record. The fossil record gives us a picture of the life on Earth or the natural history of our planet. It will tell us about the kinds of organisms that used to exist. It will tell us about mass extinctions. It will tell us about new species showing up in the fossil record. And there is a certain degree of bias because it's not every single animal that's preserved, but it does gives us a very good picture of how life used to be and the processes that it went through for life to change over time. So it shows us patterns of biodiversity just like we can see it today. And this allows us to have a greater time to actually explore the process of evolution. And in fact, if you were to try to explain the fossil record without the theory of evolution, you would have to come up with some very convoluted explanations, some of it which include great conspiracies of science to try to fabricate data. This is not data that's being fabricated. To study the history of life, because they can tell us about the progression of life and how life has changed over time. One special type of fossil is called an index fossil. Index fossils are fossils that only exist up to a certain point, or that only exist during a certain era of the history of the Earth, like the ones you see in the pictures on the bottom right there. Now what that means is that you can use the presence of that fossil in a rock to help date that rock. For example, if you find a trilobite in a rock, you know it must be from the Paleozoic area, because no rocks after the Paleozoic area have trilobites. Trilobites went extinct at the end of the Permian period. That means that if you see trilobites, it must be a rock that's at least 250 million years old. So you see how you can use the index fossils to help date the rocks. Likewise, fossils like ammonites and belemnites are from the Mesozoic area. They did not survive the Cenozoic extinction, so that means that if you see those fossils, you know they're from the era where the dinosaurs used to dominate the Earth. And scientists use these index fossils to kind of find out what certain layers of rock, what time period certain layers of rock belongs. Sometimes areas of rock are elevated or go down because of movements of the crust, but you can use these fossils to help identify, what area is older and what area is younger. So index fossils, again, are fossils used to time the rock, to date the rock, because they are fossils that only occur in certain areas of the Earth. Now, at the progression of the fossil record, and we can see how evolution made changes in life. Sometimes we have gaps that we don't have that leap, and a lot of people use those gaps to say, hey, see, there's no explanation for how you go from here to there. Now, scientists usually end up finding a lot of these missing links, actually, and they actually do continue the research and end up localizing fossils to bridge the gaps. And in fact, there's a lot of fossils that to bridge the gap, and we call those transition fossils, the ones that show how one organism became a different one, so how a species becomes another species.
Perhaps the most damaging blow to Darwin's theory is the fossil record. If all living organisms have descended from the same primitive life form, then the rock strata of the Earth should be filled with the fossilized remains of animals that were once part of a great evolutionary chain. A chain of small biological modifications, ultimately leading to a spectacular diversity of life. Yet, after 2 centuries of research, highlighted by excavations in southern China, the multitude of transitional experiments, or missing links, that should exist, are conspicuous only by their absence. The most graphic example of this void in the fossil record is a geological era known as the Cambrian explosion.
The branching tree pattern of Darwin's theory is actually not seen anywhere in the fossil record unless we impose it with our own minds. So the Cambrian explosion is the most dramatic refutation of the tree of life.
The Cambrian explosion of life was a dramatic episode in geological history. Usually dated at about 530 million years ago, the exquisitely preserved Cambrian fossils reveal that the body plans for virtually every major animal phyla appeared, not gradually and slowly as Darwin had speculated, but instead with astonishing suddenness.
If we imagine the whole history of life on Earth taking place in one 24-hour period, the current standard estimates for the origin of life put it at about 3.8 billion years ago, let's say 4 billion. So if we start the clock then, our 24-hour clock, 6 hours, nothing but these simple single-celled organisms appear, the same sort that we saw in the beginning. 12 hours, same thing. 18 hours, same thing. 3/4 of the day has passed, and all we have are these simple single-celled organisms. Then at about the 21st hour, in the space of about 2 minutes, boom, most of the major animal forms appear in the form that they currently have in the present. And many of them persist to the present, and we have them with us today. Less than 2 minutes out of a 24-hour period. That's how sudden the Cambrian explosion was.
Let me explain how carbon dating is supposed to work. Carbon dating was not invented until 1949, in the last 60 years. So when they started telling the kids the Earth is billions of years old, back in 1830, they didn't tell them because of carbon dating. They'd never thought of carbon dating, never been heard of, okay? Why were they teaching the Earth is billions of years old 160 years ago? The geologic column is where it all started. We covered that on video 4 and some more on video 6 about the geologic column. The Earth was divided up into layers: Cenozoic, Mesozoic, Paleozoic, Archeozoic. Each layer was assigned a name, an age, and an index fossil. We covered that on video 4. Then they said, now we have to prove these layers are old. So they picked the numbers, and any dating technique that comes along, like carbon dating or any other, has to match the geologic column or it's rejected. Only because the geologic column's been taught for 180 years now. So surely it's true. Well, we know the geologic column is established, therefore any carbon dates we get should match that. If they don't, we'll throw them out, and we'll keep testing till we do. They might have to test a sample 5 or 6 times till they get the number they want. Well, how do you know any of them are right then? If you're getting a different number every time, how would you know any of them are right? Radiometric dating would not have been feasible if the geologic column had not been erected first. Ever since William Smith at the beginning of the 19th century, fossils have been and still are the best and most accurate method of dating and correlating the rocks in which they occur. Apart from very modern examples, which really are archaeology, I can think of no cases of radioactive decay used to date fossils. They don't date fossils by carbon dating, they date them by their geologic position. That's how it's done. Earth's atmosphere is about 100 miles thick. But the Earth's atmosphere contains mostly nitrogen, 78% nitrogen, 20%, 21% oxygen, a little bit of CO2 for plants to breathe. Plants breathe in carbon dioxide, and there's a very tiny little bit of radioactive carbon-14, 0.0000765%. This radioactive carbon-14 is different than regular carbon. It's produced by radiation striking the sun, striking the atmosphere. Sunlight strikes the atmosphere, slaps the nitrogen around, and turns it into carbon-14. So it all starts by the sunlight hitting the atmosphere. Just to give you the procedure here, about 21 pounds of carbon-14 is produced every year, and that is spread out all over the world. Real tiny amounts. If you look at a periodic table, carbon and nitrogen are right next to each other. Nitrogen has an atomic weight of 14, carbon has an atomic weight of 12. But if the sunlight slaps the nitrogen around, it'll knock a few things off of it and it becomes carbon-14. So it still weighs as much as the nitrogen, but now it's considered a carbon. It's called radioactive. It's just, it's unstable and it's going to break apart. Carbon-14 is unstable. It does not like being carbon-14. It wants to get out of this situation. So it breaks down. About half of it will break down on a statistical average. About half of it is going to fall apart every 5,700 years. Now it is doing this on a purely random procedure. I mean, you got a pile of molecules, you never know which one's going to fall apart. But statistics tell us about half of them will fall apart every 5,700 years, roughly. Now, while it is carbon-14, it's floating around in the atmosphere, like the rest of the carbon, and it latches onto oxygen, like carbon often does, and becomes carbon dioxide. And the plants are breathing in CO2. Animals come along and eat the plants. So the only way carbon-14 gets into the living world is from the atmosphere. It's produced by the sun, striking the atmosphere. Plants breathe it in, animals eat the plants. Probably during your lifetime you've either eaten plants or you've eaten animals that have eaten plants. Well, the plants are absorbing CO2. Some of it is radioactive. So if the atmosphere contains 0.0000765%, it is assumed that the plants also have 0.0000765%. So probably you have 0.0000765% carbon in you. When the plant or animal dies, it stops eating, stops taking in more C14, it stops breathing. Okay? Now whatever it had is going to decay. It was decaying while it was alive, but now there's nothing to replace it. So what they do is they compare the amount of C14 in the fossil with the amount in the atmosphere and say, wow, this fossil's only got half as much. Therefore it's been dead for one half-life, 5,700 years. Because it continues to decay after it died, but now it can't be replaced. So while it was alive, it should have had about 0.0000765%. If it's only got 0.0003825%, it's been dead for one half-life, or two half-lives, or three half-lives, etc. In theory, it never goes to zero. But for practical purposes, you can't measure beyond a certain amount. You know, you're going to run out of stuff to measure. It goes from a half to a fourth to an eighth to a 16th to not enough to measure.
When an organism dies, the carbon-14 that was present remaining at the point of death is what would be detected radioactively. A piece of wood, for example, or a bone would contain a small amount of carbon-14. When the tree which bore the wood or the animal which bore the bone died, that carbon-14 that remained is decaying. It takes thousands of years for the decay process to occur. About 5,760 years for half an original amount of carbon-14 to decay into a stable isotope of carbon-12. So by measuring how much of it has decayed, an indication of how long ago the organism was alive can be obtained. As rocks were never alive, they contain no carbon-14. Even the fossils in the rocks cannot be dated by this method because the original living matter in them has turned into stone.
Does this mean that the fossils can't be dated by radioisotopes?
Well, certainly not by carbon-14 with any degree of reliability. As you know, virtually all the fossils are found in sedimentary rocks, and because this type of rock rarely contains radioactive elements, the fossils have had to be dated by rock strata in which they are found. And as we know, the latest experiments show that rock strata give no indication of age. Other types of rocks, such as crystalline rocks, which do not contain fossils, and lava do sometimes contain radioactive elements, and these isotopes are used to date them.
Can you tell us, in simple terms, how you date a fossil or rock with a radioisotope?
Yes, let us take a radioactive element such as uranium. This element decays very slowly into a non-radioactive element, which is lead. Now, the rate of the decay can be measured in the laboratory. So by comparing what's left of the uranium element in the rock with the amount of decayed lead element that was formed, and knowing the rate of decay, an idea can be had of how long it has taken for the lead to form.
So, if half of the uranium has decayed into lead, and by knowing how long it takes for uranium to decay into lead,
yes,
you can tell the age of the rock.
That's the theory.
Why do you say theory? Surely if it's a process you can observe and measure, it must be a fact.
Not at all. Look again at the diagram. You can see that there are a number of uranium particles, the orange ones, and a number of lead particles, the blue ones. Here we have to make three major assumptions. The first is that all of the lead particles were originally uranium particles, but there is no reason to believe that there were not some lead particles in the rock when it was formed. You see, there's plenty of natural lead in rocks that doesn't come from uranium at all.
Really?
Yes. Let us take the extreme case. If this rock contained radioactive uranium and no lead, then the lead that would appear as a consequence of uranium decay would be a fairly accurate measurement of the age of that rock. Or to take a more likely situation, that at least some of the lead was in the rock when it was formed, then the age of the rock is much less than we are led to believe. Then there's the matter of leaking out due to solubility.
Could that happen?
Most definitely. Salts of uranium and other radioactive elements are quite capable of dissolving in water and therefore will be removed from the sample. So if the rock had been exposed to water for some period of time, such as during a flood, some of the uranium could have been washed out. This would mean that the age ascribed to the rock would be much too great.
But surely there must be other radioactive material and elements which are more reliable than uranium.
Well, there's radioactive thorium, and there is strontium and rubidium, and there's potassium. But these are no more reliable than uranium. The salts of these latter elements are even more soluble in water than uranium salts. Let me give you an example of how water can affect radioactive dating. Less than 200 years ago, the Hawaiian volcano Kilauea erupted, and the lava which emerged from that eruption was submerged in water. It was subsequently dated by the potassium-argon method. Clearly, it should have shown the age of the lava to be about 200 years. The date recorded, however, was 22 million years. Obviously, the highly soluble potassium salt had leaked out of the sample and left it looking very old. Other samples taken from Haulula'i volcano lava from 1801 were dated between 160 million and 3,000 million years old.
The situation gets worse and worse.
But there's also another assumption in radiometric dating, and that is that the rate of decay has remained constant and has not been influenced in the past. There are a number of things which could have influenced rates of decay.
Such as?
Well, the production of neutrinos from cosmic radiation could have been enhanced by a reversal of the Earth's magnetic field or the explosion of a supernova in a nearby star. Science has proclaimed that these events have occurred in the past, and they could have a substantial effect, therefore, on the radioactive decay rate. So,
carbon dating cannot be denied is a highly inaccurate way of dating organic remains. It's not just that it's inaccurate, it's even worse than that. There have been numerous cases in the past where objects were carbon dated and the date that was then established was found to be wildly off the mark, completely wrong basically. Now, given that we realize this and we accept this, how do we respond to that disappointing result? What do we do? Well, we could of course do what the creationists do. We could just denounce carbon dating and say, this is a load of bullshit, it's not working, and therefore we will not accept anything that ever has been found out by carbon dating. The first thing. The second thing is that carbon dating does only work for something in the region of up to 10,000 years or thereabouts. You know, that's sort of ballpark. The method by which tree rings are used. Basically what scientists have done over the years, they've accumulated a database of tree rings based on separate finds and calibrated to fit each other. What that means is that, for example, we have plenty of wood from the last few hundred years. And of course the tree rings in wood do indicate the succession of good years and bad years for tree growth. As a result, it is possible to match up older samples of tree rings with newer ones. Because if a tree was, for example, born 100 years ago and has grown up to today and gets cut down, you get a certain pattern of tree rings. But imagine you got another tree that was born 150 years ago and cut down 50 years ago. There's 50 years of overlap between those two trees where both of them were standing. And if you look at the tree rings for those two trees, you will see that the pattern for those 50 years will be identical for those two trees, provided of course that they were standing in a similar area with a similar climate.
The oldest known individual tree was discovered in 2012 in the White Mountains of East Central California, a great northern bristlecone pine that's 5,063 years old. That's older than the pyramids. Here's a photo of a similar bristlecone pine. Now, it doesn't look exactly alive, and that may be part of its secret to success.
Great article came out from Institute for Creation Research. They're the ones that did the RATE project, ICR.org. They said, with their short 5,700-year half-life, no carbon-14 atoms should exist in any carbon older than 250,000 years. They should all be gone. Yet it's proven impossible to find any natural source of carbon below the Ice Age that does not contain significant amounts of carbon-14. Even though such strata are supposed to be millions or billions of years old, conventional carbon-14 laboratories have been aware of this anomaly since the early 80s and have striven to eliminate it and are unable to account for it. Lately, the world's best such laboratory, which has learned during 2 decades of low C14 measurements how not to contaminate specimens externally, under contract to creationists, they confirmed such observations for coal samples and even for a dozen diamonds. Now think what that means. The textbooks will tell you coal formed 250 million years ago in the Carboniferous era. And yet when they test coal, it still has carbon-14. How is that possible? If all the carbon-14 atoms would have disappeared in, say, 30, 40, 50,000 years, why would there still be carbon-14 atoms in coal? I got an idea. It's not 250,000 years old? Ooh, boy, they don't like that answer. They'll keep searching until they find another answer because they don't like that one for sure. And diamonds, which they say, formed millions and millions of years ago, they still have carbon-14 in them. And it's not possible to contaminate one of those things. I mean, it's the hardest substance we have. So how do you get carbon-14 in diamonds? If you find a fossil in the dirt, the amount of carbon can be measured, the rate of decay can be determined. I don't argue with either of those. How much was in it when it lived? I don't know. Has it always decayed at the same rate? I don't know. Has it been contaminated, sitting there in the ground for all these millions of years? There's no way to know those things. And when we dig up the fossil that's been buried for 4,400 years, let's say it started with 4, where today we start with 16. Well, we're assuming it started at 16. When we test it and find it's got 2, we're going to say, oh, it's been through 4 half-lives, when it's actually only been through 1 half-life. Which is why it never works. When they first invented carbon dating, 1949, Willard Libby, they did some testing and they said the lower leg of a mammoth was 15,000 years old, but the skin was 21,000. How can 2 parts of the same animal be different ages? Quite obviously, we know one of the numbers is wrong. So how would you know either of them are right? And if either one's right, how would you know which one? I see no way to tell. Well, let's see if it's getting better. 14 years later, they tested a living mollusk, a clam, and it was 2,300 years old. Still alive. In 1970, at the Nobel Symposium, they said, if a carbon date supports our theories, we put it in the main text. If it does not entirely contradict them, we put it in a footnote. If it's completely out of date, we just drop it. You mean they can pick and choose any numbers they want? Exactly correct. If the number doesn't fit what they expected, they throw the number out. 1971, freshly killed seal was 1,300 years old when they carbon dated it. Troubles with carbon dating are undeniably deep and serious. Despite 35 years of technological refinement and better understanding, the underlying assumptions have been strongly challenged and warnings are out that radiocarbon dating may soon find itself in a crisis situation. Continuing use of the method depends on a fix-it-as-we-go approach, allowing for contamination here, fractionation there, and calibration wherever possible. It should be no surprise then that fully half the dates are rejected. Did you follow that? Out of thousands of carbon dates that have been carbon dating times that they've done it, half of the numbers are thrown out. How do they know they're wrong? And also, how would you know the other half is right? If half your test results have to be thrown out, it ought to raise red flags in somebody's brain. Wait a minute. This is stupid. What are we doing? We're wasting our time here. And the article goes on to say, the wonder is, surely, that the remaining half have come to be accepted. No matter how useful it is, the radiocarbon method is still not capable of yielding accurate and reliable results. There are gross discrepancies, the chronology is uneven and relative, and the accepted dates are actually selected dates. This whole blessed thing is nothing but 13th century alchemy. And I agree. That's 1981. Now, I've got all these in chronological order. It never gets better. 1984, living snails carbon dated 27,000 years old. 1992, two mammoths found side by side. They carbon date them. One is 22,000, the other is 16,000. 1996, Carl Swisher at Berkeley University used the most advanced techniques to date human fossils. Says last spring he was reevaluating Homo erectus skulls found in Java in the 1930s. He was testing the sediment found with them. The species was supposed to be extinct for 250,000 years. Swisher used two different dating methods. He kept making the same startling find. The bones were 53,000 years at most and possibly no more than 27,000. Well, I'd like to point out two things here. He's looking for 250,000 as his answer, but he keeps getting 53 to 27,000, okay, which is only 1/4 of what he wants, 1/5 of what he wants, okay? But he's still getting a 96% error. So when they publish an article in the paper and say, we found a dinosaur bone or a mammoth bone and it was, 17,221 years old in 6 months and 3 days. Like, right, come on. You don't know that. They're making up this stuff, just absolutely making it up. Professor Rainer Prach von Zeiten, earlier this February of 2005, was resigned from a professor because he'd been lying about carbon dating for years. His frauds were exposed in February of 2005. He had dated the Bishkopf spire skeleton at 21,300 years old, but when they tested him at Oxford, they said it's only 3,300 years old. 700% error. He had said, Professor Prach had said he had found the oldest German, the first German to ever move to Germany, 27,400 years old. They tested it at Oxford and said, this is an old man that died in 1750. He's 250 years old. The professor had been lying about this stuff for decades, and so he finally resigned. One part of a mammoth dated 29,000 years old, another part was 44,000. You talk about a slow birth. That would be it, okay? I like this article from Rand McNally. The last 2 years, an absolute date was obtained for the Gandong beds above the Trinil beds. That's in Indonesia. It has the interesting value of 300,000 years, plus or minus 300,000 years. In the Geological Survey Professional Paper 862, there's all kinds of articles about carbon dating things in Alaska. I just want to show you a few things here. They carbon dated sample number SI454. See that on the map there, on the chart there? And said it was 17,210 years, plus or minus 500. Then they tested sample SI455 and said it's 24,140 years old. Well, 17,000, 24,000, say, wow, that's working good, until you find out that's the same sample as 454. Very same sample. Test it again. So is it 17,000 or 24,000? Sample number 299 was less than 20,000 years old. That little caret means less than. Sample number L137X is greater than 28,000. We say, well, see, it's working good. This sample is less than 20,000. This other sample is greater than 28 until you find out it's the same sample as 299. How can a sample be less than 20 and greater than 28 at the same time? That's not too good. Living penguins were dated at 8,000 years old. Materials from layers where dinosaur bones were found are carbon dated 34,000 years old. But yes, dinosaurs ought to date, 70 million years old. A Russian scientist dated dinosaur bones at less than 30,000 years old. Hugh Miller from Columbus, Ohio, took in 4 dinosaur bone samples and said, would you carbon date these? And they charged like $600 to carbon date something. They carbon dated them and said they're less than 20,000 years old. He said, oh, by the way, these are dinosaur bones. They said, oh, well, then they're not 20,000. We've got to test them again. Why can't they be 20,000? They said, well, we know dinosaurs lived 70 million years ago, so if you had told us that, we never would have carbon dated them. One friend of mine died here several years ago, but he was digging, doing a lot of archaeological work, and he dug down in this well and he found layers of burned wood, which is good to carbon date because obviously, you know, it had carbon in it. And he put them in a baggie, sample number A, from such and such a layer. How many feet down, he labeled it A. Dug down 10 more feet, hit another layer of burned wood. A city had been destroyed, or 20 feet, whatever it was. He labeled it sample B. He took them in to have them carbon dated. Paid them the $600. They said sample A is, I forget, 3,000 years old, and this one's 4,000 years old. He waited 6 months, switched the labels, took them back in, same laboratory, said, I want you to carbon date these samples. Now, sample B, the lower one, is in the top bag. Just switch the labels, and they give them the same results, 3,000 and 4,000. It doesn't work. It's never worked. Here's things to consider about carbon dating. When the sample of, you date a sample of known age, it doesn't work. If you date a sample of unknown age, it is assumed to work. That's not science, okay? As things decay, they produce helium. This helium, the amount of helium in the atmosphere is only enough to account for a few thousand or few million years, not billions of years. This guy said the rocks do date the fossils, but the fossils date the rocks more accurately. That's ludicrous, okay? And it all based on circular reasoning. They've known that for centuries. We'll cover more on that on video 4. I talked to James P. Dawson. James Dawson was one of the guys working on dating the moon rocks. They brought back moon rocks, gave them to his laboratory, and said, how old is the moon rock? He took specimen number 10017, divided it into 6 pieces, and tested it many, many times. How old is it? They got numbers ranging from 2.5 billion to 4.6 billion. That's a 500% error, or 100% error. I talked to him back in '99, and he's in Oklahoma. There's his phone number. He was Chief of Engineering and Operations for the Lunar and Earth Science Division of the Manned Spacecraft Center in NASA in Houston. He worked on lunar samples, including the Genesis rock. He told me they found ages from 10,000 years to several billion in the same rock. His website, jpdawson.com. How can one rock be 10,000 years old and several billion years old at the same time? Something is wrong, okay? See, the theory is important. The facts are not. What about potassium-argon dating? Does that work? Actually, the numbers are bigger, but the problems and assumptions are exactly the same, and you can demonstrate it doesn't work. Potassium decays very slowly. This chart shows the different elements and their half-life. Carbon has a half-life around 5,700 years, but potassium, it takes 1.3 billion years with a B for half of that to disappear. Very slowly decays. By the way, I would like to point out, Your Honor, just for, appeal, that all of the dating methods are based on the decay of an element. Uranium decays to lead. Potassium decays to argon. They're all moving down the periodic table, not up. All going down. Just point out, keep that in mind in case we need to appeal this case, all right? 80% of the potassium in a small sample of iron meteorite can be removed by distilled water in 4.5 hours. Well, if you can take out 80% of it in 4.5 hours, how can you trust any dates you're going to obtain by that? Canadian Journal of Earth Science ran an article and said, in conventional interpretation of potassium-argon age, it's common to discard ages which are substantially too high or too low compared to the rest of the group, or with other available data such as the geologic time scale. There it is. If you test a sample and its number's too high or too low or doesn't match the geologic column, it gets thrown out. Well, then why are you wasting your time and money testing it? You already know how old you'd like it to be. Give it a number. Pick a number. It's dumb. The KBS tuff, a tuff is a layer of ash or lava, or generally ash that has been packed and turned into rock. It's called tuff, T-U-F-F. K. Brenzenmeyer had been dating these samples of with potassium-argon dating because here's the theory. When a volcano erupts, the rocks and stuff coming out is really hot and any gases in it should be able to escape. Well, potassium slowly turns into argon, and argon is a gas. They use it for welding over at the shop. Argon welding, Argon's a gas. So since potassium turns to argon, when the rock gets melted and shot out of a volcano, all the gas escapes, and so the theory says this new layer should have been, the clock is now reset. It is 0 years old. Even though when it was in the Earth, it's 4 billion years old. Now all the argon's gone because it accumulated this argon for millions of years, but now, poof, it melted and the gas is gone. So we can potassium-argon date this lava or ash or any volcanic material. Well, they had been dating this layer of ash named after Kay Brenzenmeyer because she did research on it. They said it's 212 to 230 million years old. All the scientists agreed that layer of ash is around 200 million years old. Until Richard Leakey came along in 1972, and he's digging around under the KBS tuff, and he finds a perfectly normal human skull. Everybody panicked and said, wow, how can you have a normal human skull under 200 million year old rock when man didn't even evolve till like 3 million years ago? That's not possible. And so they looked for things. Was this a burial? Did somebody dig through the rock and bury this person down here? Was there an earthquake? Is there a fault line near here someplace? Nope. All we can conclude is there's a normal human skull under 200 million year old rock. So, what do you conclude? Well, one group studied this and said, well, that proves aliens came here 200 million years ago. Would you just consider that maybe the rock's not 200 million years old? After they found out it could not be an intrusion or a burial or anything else, it had to be legitimately placed there. I mean, the person was buried under this ash layer. They took 10 more samples of the KBS tuff and dated them again. Keep in mind, they'd already dated them a bunch of times. And everybody agreed it's 212 million years old. But now they take 10 more samples and check them again and say, oh no, it's only 0.5 to 2.6 million. Well, that's way down from 212. Okay, they dropped the number way down. But they're still getting a 500% error from 0.5 to 2.6. This is not an exact science. Well, then why are you wasting anybody's time? Why? It's not science. The original content cannot possibly be known. You can't know there's been no contamination. You can't know that the decay rates always remain the same. You can't know those things, okay? I'll give you a couple examples of potassium-argon problems, and then we'll take a little break. Basalt from Mount Etna in Sicily. By the way, I climbed on Mount Etna when I was over there in Sicily. They knew it erupted in 122 BC. They said they knew it erupted in 122 BC. There were written records. Well, the potassium-argon dated it and said it's 2.25 million years old. Excuse me? It should be like 2,000. When they tested lava from a Hawaiian volcano, they knew it erupted in 1801. The people watched it happen. That's the lava flow that covered our village, 1801. It gave an age of 1.6 million years old. That's in 1968. Let's see if it gets better. Basalt from a volcano in Hawaii erupted in 1959. When they tested it, it gave an age of 8.5 million years old. Another volcano in Mount Etna from the 1964 eruption gave an age of 700,000. The 72 eruption gave an age of 350,000. It was erupting when I was over there in 2002, I believe. I don't remember. Lava from Mount St. Helens was tested, which my sister lives just 60 miles from there. They tested the lava from Mount St. Helens, brand new lava coming out of the volcano. Grab a sample. How old is it? They tested it 5 different ways and got 5 different numbers. All the way from 350,000 to 2.8 billion. Notice, all 5 numbers are different, number 1, and all 5 numbers are wrong, number 2. They're wrong. It doesn't work.